You're listening to the Bare Metal Cyber Prepcast, created to help you succeed in your Server Plus certification journey. Learn more at baremetalcyber.com, where additional prepcasts, books, and training materials await. Let's get started. Storage management in server environments refers to the allocation, configuration, and monitoring of disk space to ensure optimal performance, data protection, and scalability. This includes managing volumes, setting quotas, enabling compression, and monitoring usage trends. Proper storage management ensures that servers have sufficient capacity, that critical services do not run out of space, and that administrators can respond proactively to growth or system changes. Server Plus includes provisioning, data optimization, and role-based allocation. Effective storage management is essential to prevent downtime and maintain service quality. If storage is not allocated and monitored carefully, servers may crash, services may halt, and updates may fail due to insufficient space. Administrators must balance available capacity, workload demand, and redundancy to avoid performance degradation. Using monitoring tools and storage policies ensures that the infrastructure remains healthy and supports future expansion with minimal disruption. Provisioning is the process of allocating physical or logical storage space for use by the operating system, applications, or users. It defines how much capacity is available to each resource. Thin provisioning allows administrators to allocate space as needed, presenting more capacity than physically available. Thick provisioning, by contrast, reserves full space up front, reducing the risk of overcommitment. The Server Plus certification includes choosing the appropriate method based on workload and risk. After provisioning, storage must be formatted with a file system and mounted to make it usable by the operating system. Mount points define where data appears within the file system tree. For example, a volume may be mounted at /data or on drive D. Configuration must ensure that these mount points persist after reboots. Server Plus includes creating persistent mount configurations and understanding how auto-mount tools function across platforms. Disk quotas place limits on the amount of storage a user or group can consume. These quotas help prevent individuals from accidentally or maliciously using excessive space, which can affect other services. Administrators may configure warning levels where users are alerted and hard limits where further rights are denied. Quotas are especially useful in multi-user environments or shared workspaces where oversight of storage consumption is necessary. Compression tools reduce file size by removing redundancy, allowing more data to fit into the same physical space. On Windows, NTFS supports built-in file compression, while Linux systems may use compression-capable file systems such as BTRFs or tools like gzip. Compression conserves disk space, but may add CPU overhead during read and write operations. Administrators must decide whether the storage savings justify the potential performance cost. Deduplication eliminates duplicate instances of data, particularly useful in environments with similar virtual machines or frequent backups. The system identifies identical blocks or files and replaces them with references to a single copy. Deduplication saves space but may increase complexity. Improper implementation can lead to fragmentation, performance delays, or data corruption if the references are damaged. Planning and validation are critical before enabling deduplication in production. Monitoring disk usage over time allows administrators to anticipate when expansion will be necessary. Tools such as DF and DU on Linux or Performance Monitor on Windows display storage utilization. Trend data can be collected and visualized to forecast growth. Alerts help administrators intervene before critical volumes fill up and services are impacted. Server Plus includes identifying when space usage has reached alert thresholds and initiating proper action. Expanding storage dynamically allows servers to scale without downtime. Administrators may add physical disks or expand virtual disks and then resize logical volumes or file systems. On Linux, logical volume management tools can extend volumes. On Windows, storage spaces provide similar functionality. File systems must support online resizing or scheduled downtime must be planned. Dynamic expansion ensures services continue uninterrupted as demand grows. External or remote storage can be mounted to extend server capacity. Network file system and server message block are common for file-based access, while ISCSI provides block-level connectivity. Mounts can be scripted for automation and persistence across reboots. Security is essential when using remote storage. Access should be protected by credentials, and firewall rules must limit exposure. Server Plus includes setting up secure and stable remote mount configurations. A tiered storage strategy matches data importance with storage performance. Frequently accessed or latency-sensitive data should be stored on fast devices, such as solid-state drives. Less active data, such as archives, can be moved to traditional spinning disks. Tiered storage reduces cost while preserving performance where it matters most. Matching workload types to the appropriate tier is a key aspect of infrastructure planning and long-term storage efficiency. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Automated storage management tools reduce manual overhead and support faster provisioning. Technologies such as storage spaces on Windows, ZFS on Unix systems, and logical volume management on Linux allow scripted creation and expansion of storage. Automation ensures consistency and speed, but introduces risk if not properly monitored. Administrators must implement alerts, logs, and guardrails to prevent misconfiguration, unauthorized expansion, or unnoticed failures during scheduled tasks. Storage pooling and virtualization allow multiple physical disks to be combined into a single logical unit. This abstraction enables flexible allocation, simplifies resizing, and improves redundancy. Logical volumes created from storage pools can be assigned to specific services or users without being tied to a single physical drive. Storage virtualization also helps manage large environments by separating hardware layout from logical presentation, supporting faster provisioning and better resource utilization. Security practices for storage systems include encryption, access control, and audit monitoring. Sensitive volumes should be encrypted using tools like BitLocker for Windows or LUKS for Linux. Access must be controlled through file permissions and access control lists, limiting exposure to authorized users only. Administrators should log access attempts, monitor permission changes, and audit usage regularly to prevent unauthorized data access and detect potential breaches. Backup and archiving strategies are key components of long-term storage management. Backups must be scheduled, versioned, and stored on separate media or in remote locations. Archived data that is no longer active should be moved from primary storage to reduce load. Lifecycle policies help automate this process. All backups should be tested regularly, and any backup system must include monitoring to detect failure, data corruption, or missed schedules. Storage alerts and threshold settings provide early warnings about capacity issues. Thin provisioned environments are especially vulnerable to sudden exhaustion. Administrators must define thresholds for warning and critical states and configure alerts that reach responsible teams via email or dashboard notifications. These alerts support proactive response and prevent service interruptions. Proper alert configuration is a core requirement of reliable storage oversight. Disaster recovery plans must account for storage systems and how to restore data after failure. Snapshot technologies, replication, and mirrored volumes allow for fast restoration of lost data. Restore tests should be conducted quarterly to validate recovery time objectives and recovery point objectives. Storage maps that identify volume locations, dependencies, and priorities help guide recovery efforts and avoid confusion during high-pressure incidents. Documentation is essential to track how storage is used and maintained. Records should include volume names, mount points, usage purposes, assigned quotas, encryption status, and access permissions. Diagrams should show how storage is connected to applications, clients, or shared services. Logs and configuration files must be stored securely and reviewed during audits or change control. Documentation supports faster troubleshooting, efficient upgrades, and effective disaster recovery. Storage management is a critical function that affects every service running on a server. Proper provisioning, quota enforcement, compression, and deduplication ensure efficient use of available resources. Monitoring trends, documenting layouts, and securing data are part of every administrator's responsibility. In the next episode, we will explore server monitoring tools and alerting strategies to ensure that systems remain visible, responsive, and secure at all times. Thanks for tuning in to the Bare Metal Cyber Prepcast, your trusted source for cybersecurity news and insights. Remember to subscribe at baremetalcyber.com so you never miss an update. And visit cyberauthor.me for best-selling cybersecurity books that equip you with expert knowledge. Until next time, stay secure and stay vigilant.